There's so much objectivity talk in and around mathematics, especially as it's applied to computer science. I don't think it's actually very fair. I think that all of mathematics is effectively input output. If I assume this, then I get that. And there are some assumptions that are closer to universally useful, in which case, almost as if they were universal truths, but they actually aren't. A lot of my work involves things on the edges of common assumptions. So we do a lot of work with spaces that maybe really aren't metric spaces. You can make assumptions about them. Like you say, here's this complex space that represents some phenomena, and I actually have to equip it with a metric to do something like a gradient descent. But I would argue that metric is not a global metric that belongs to the space. It's actually a metric that belongs to me in my interaction with the space. I want the system to move in a particular direction, but maybe you want that system to move in a different direction. But there's nothing to say that you share that metric if the space is sufficiently complex. And thus, if I try to say, oh, no, this is the metric for everyone, you could argue that I'm actually imposing my value system on other people, because the space isn't actually equipped with that metric automatically. I am equipping it.
So let me say this and see if it resonates for you. There's the territory, the map, the GPS system, and the directions.
Okay, I like it.
Putting a metric on a space, you're taking a territory and you're giving it a map. And what people want to do is to build a program like the GPS coordinates that can just tell them where to get. And really what they want are step-by-step directions usually.
Yeah, I think that's good. I might have to expand it one more level to get my intuition, because there's the territory, which I think of as inherently complex and something that we couldn't totally represent. The map, in a way, is our abstraction that maybe bleeds away some of the finer details, but ultimately captures what is essentially important to this case. So in our case, with the GPS, this might be like the road system. Like the roads are on there, but we're going to include and exclude certain types of passageways that might not suit the use case. They're not there. Our map just simply doesn't have them. So once we get past that, now we have our space. In the navigation sense, it's some sort of graph. All right, the next step then is to ask, what is our optimization objectives that we're going to use? So in our software, we might have to care about things like, are we optimizing for the shortest time, or am I avoiding freeways? This actually is about encoding the optimization objective. So we actually can already introduce subjectivity when we give affordances for what kinds of things can be optimized for. As you move into the more tactical element, it needs to know where you want to go and which optimization criteria you've chosen. Then it can solve the problem and dynamically give you directions by giving you the next step on the best route according to what you described the best route as being. But if you remove the freedom to select what means best, you are actually, again, imposing an assumption on the user that maybe they don't want you to impose.
This is what I would say with that. If our assessments and classes or our tests are based on did you get from point X to point Y, then students look for lists of directions that get them from X to Y. In searching for that, they miss the links that you develop by actually walking the territory. Now, a map can be really useful. You want a map that you don't end up in a dangerous place or way, way far from your objective.
I would go beyond that even. Yeah. I think this is there's an ethical obligation to do this if you're a map maker. So if you are a map maker, to be able to step down into the territory and engage with it is critical, because what you include or exclude from the map affects the people who use the map. If I leave a town off the map and or maybe even exclude it from the trading logs, or like these cyber layer things that start to express the territory, then you're in effect sanctioning that town because you are excluding them from the map. You're excluding them from the trading log, and they have less trade, so they're even less likely to show up in the trading logs. You recursively isolate them through exclusion, not from the territory, but from the map. When we think about software as a sort of tight entangling of map and territory, a bit like this somewhat stylized example with regards to things like the maps and the signposts and the trading logs and these data manifestations that we get embedded in the territory that affect the use of the territory. I am of the opinion that most of the software systems, at least that we're building in Web3, have analogs to these kinds of trading logs and signposts and maps. And that if you try to build the maps and these sort of metadata structures that steer without understanding or getting into the territory, if you're just taking things off lists, you're just perpetuating the extant structures. You have no opportunity to improve or refine or represent people if you're not taking the time to get into the territory, engage with the actual phenomena, and then say, here's how we could represent this phenomena so that the people who are engaged in it can express themselves. If you stay up in the, okay, here are my math primitives and these are the answers and I just use them, you're not actually engaging in the act of making maps. You're like a map copier. You're not a map maker. Map maker has to understand both the essence of the tools and the act of representing and the effect the act of representing has on that which is represented. And that's where the problem framing stuff really comes back in, where, to be honest with you, anybody can learn to solve a convex optimization problem, import the right algorithms, look up the right methods. What we need are people who are engaged in framing and mapping, and that those people are not just doing it from grabbing the building blocks, but actually have built up enough intuition to think about the consequences of their choices. I'll use a concrete example to round out that. In convex optimization, as it could be applied to something like social choice theory, there's a really common example. It's attributable to Rawls, I believe. If you do a sum of utility functions, you will favor the terms associated, let's say that's a sum of people. If people have highly sensitive terms, then they would get higher marginal utility. If you do this, then unfortunately what it tends to do is route the resources to those people disproportionately, almost always at the expense of other people. That from us, if your definition of optimal is the largest sum of the utilities, then that's optimal. But what it doesn't do is provide for the people at the other end. They might get, because their utility functions are not sensitive enough, say. You address this in part through min-max optimization. So instead of summing, you take the minimum. And so to our discussion earlier about building blocks, it turns out that the minimum of a bunch of convex, I have to make sure I do this in the right direction, because in social utility problems, it's usually a max of a concave. So you were maximizing the sum of a bunch of private concave utility functions. So what you do is you minimize the minimum of them instead of maximizing the sum of them. And that min-max technique means that you're bringing up the bottom as opposed to increasing the sum. Even if everything else is equivalent, if all you did was swap from the sum of the private utility functions to min-max, you get a radically different resource distribution. I think this is another one of these really good teaching examples about sensitivity to problem framing, because in both cases, a politician pitching a new policy is like, this is socially optimal. And you're like, okay, socially optimal. You've encoded what optimal means in your choice of aggregator function, and you haven't necessarily teased out the consequences. And in this case, it's incredibly sensitive. Depending on your measure of inequality, your measure of inequality will be greatly reduced, because it will greatly reduce the likelihood that someone gets nothing. It compresses the solution. Then there are other things you could construct as well. So you could come up with other measures of whether the solution is good. But what I would recommend is coming up with 3 to 5 measures of goodness of the solution, and then look at the 2 different ways of framing it and seeing how they fare across them. Obviously, one of the measurements should be the total utility. One of the measurements should be the minimum utility. And then we come up with maybe 3 other ones, like something like the gap or the Gini coefficient or a few other things. And then actually you could ask, okay, of these 3 to 5 metrics, how sensitive is the framing to it? And so you compare sum of utilities to min-max and actually make a more of a governance discussion of like, which one of these actually encodes our values? Because if we're going to use an optimization problem to facilitate making a decision or to justify a resource allocation policy, then we need to know how sensitive the framing is with respect to our goals. By mathematizing some of these things, we can turn a problem that might have been purely an intuition and discussion problem into an engineering problem by saying our requirements are resurfacing the subjectivity in the problem framing. It allows for ethical, healthy engineering process. These are their priorities, or roughly the things we want to investigate. And then once we get a family of solutions, we can look at realistically where we might land, as opposed to taking a posit that our solution is optimal. And again, recurring problem, lots of this solution is optimal language. My strong argument is that if you say that without providing your assumptions very explicitly, you're actually misleading people, because all optimization solutions are predicated and often quite sensitive to their assumptions.
The holdover from problems that are purely physical in reality, which don't have any sense of cognitive complexity. When you're throwing a ball in the, it's highly predictable.
I think that even that is a byproduct of the way it's taught, because
Mhm.
a lot of those problems are also framed to make them very objective. If I take a different one, like a signal to noise ratio problem, let's say that I have a signal that moves along and then it jumps, and then it moves flat, and then there's a little jiggling around it and a transient around the step change, and then a little jiggling. Now, a priori, you do not know which one of those things is the signal and which one is the noise. You have to impose an assumption. So I might use a low pass filter, I might use a high pass filter, I might use a band pass filter. But in order to design a filter, I need to know whether I'm trying to understand the nature of the noise or whether I'm trying to get that square wave back out. The idea that an estimation problem is predicated on your assumption or your context about what is signal and what is noise is a way more, at least in my opinion, appropriate way to teach this. So you teach the exact same stuff, you just teach it using something that it's not obvious in advance which thing you want. And so the design is of the algorithm that is an optimization problem that distills signal from noise starts from the question of what is the part that I want and what is the part I'm trying to get rid of.
You have three people with a bottle of wine. You're trying to figure out how much wine each one should get. Each one has different amounts of wine that they also have different amounts of wine that would actually be good for them. It may be that if this person drinks as much wine as they want to, it's not good for the other people. They're not pleasant when they drink that much wine. So I think that's a good starter example of it's small and you can automatically see how the different perspectives interact.
Yeah, definitely. I've been trying to get people to ask me about voting and signaling and even markets, stuff that's coming up in Web3. I actually push them when possible towards not just this Boyd and Vandenberg convex optimization book, but this series of books called Fundamentals of Statistical Signal Processing. And their estimation theory, detection theory, and practical algorithm development. It goes back to something closer to the example that I was giving with the filters, but more general, where whenever you're going to solve one of these problems, you have to try to figure out what just because the physical systems seem deterministic doesn't mean they are. And there's actually tons of literature to help you deal with problems that don't have objective answers and help you frame the problem into something that is, we'll call it locally objective or objective conditioned on the things. Like we need to assume, even in complex and dynamic phenomena like robotics, you're doing that all day. It's just that it's a little easier to decide on what's going to be a good enough assumption because you don't really have to, I don't know, necessarily speak for someone else. In a social system setting, you're designing for something that has a higher degree of expressivity because you don't necessarily to assume that you know what people's functions are, right? In the wine example, you might have the sense that those functions exist, but you may not even have any way of knowing what they are. So you have to come up with like effectively meta pattern solutions, which account for, we have the sense that this kind of thing might be the utilities. And with the mathematics or the things like convexity, convenience is knowing what the shapes in those mathematical concepts represent. So let's go to concavity for a moment. Concavity is used with your maxing utility functions all the time. In order to get well-behaved convex optimization problems in economics, you say, okay, what does that actually mean? It means diminishing marginal returns. In some circumstances, diminishing marginal returns makes a lot of sense, but in other cases, it doesn't. You wouldn't want to use a assumption that a person's utility function is concave if it doesn't have that property. It's a good assumption a lot of the time, but some people are so used to using it that they forget to check it. They don't ever ask themselves, is the phenomena that I am representing, they have this diminishing marginal returns property? Because if it doesn't, then whatever that solution is telling me is not going to help me. It might make me feel good and I can say it's optimal because I wrote an optimization problem, but that optimization problem could be a very bad representation.
I did want to say one thing to connect this back to education, which is I think one of the issues, I think you made a really good point about map copiers. And one of the problems is that the objective functions of our systems are set up in such a way that it's easy for map copying to feel like good. The person who's trying to teach about a territory comes in with their atlas of maps. Their intended assessment is to be about recreating these maps or answering questions about these maps. The students just learn to copy the maps and memorize what will be on the test. There's no incentive to spend time exploring the territory because that's messy. And so it just ends up being map copying, and people don't realize it until they get in the territory and see that they're not prepared.
It's worse than that, actually. The map copying continues into the practical domain, because you get there and everybody knows map copying and it's incentivized. Map copying, great. Look at all the maps we made. The maps get farther and farther away from the territory. You wonder why people are unhappy and why systems are not actually meeting their needs. Because we teach them to copy maps, then we put them into a workforce where they're measured by the number of times their map has been copied or the number of times the map has been used. But the question of whether the map is being used is not the same, or the number of map copies that were made is not the same as whether the map fits the territory well. So in some cases, some of the greatest harms in our society are perpetrated by the content of the maps that we are copying, that we taught people to copy, that they all feel great. They're learning to copy maps, they're applying copying maps, the maps continue to proliferate, but any of the oversights that might have existed in those maps just get further and further away from consideration, because of course that's just the map. I've seen that map, you've seen that map, we all know this map, let's use this map. If that map is missing something important, you've just made it even harder to change the map, not easier. So we have all of this systemic bias in our institutions, in our softwares and whatnot, is actually, in my opinion, a byproduct of the incentives to teach copying maps. The incentives to design and build creates a sort of fixed point in our institutional design space, because as such a strong self-attractor to the current state of the maps that it's not only difficult, sometimes it's downright impossible to make a meaningful change to the shape of the map, because people aren't comparing it to the territory. They're comparing it to the damn maps. So even if the map is wrong, you're like, the map is wrong. They're like, we all know this map, it's right. I'm like, but have you looked at the territory? Look at the map. See, look, everyone. I'm like, are you kidding me?
Even worse than that, knowledge of that particular map becomes social proof that you know the territory.
Even if you don't.
So you can talk, you know how to draw the maps in a certain style. You're expected to say things in a certain way or to know certain things before your credibility is sufficient that you can even make a statement about the territory. If you just walked in from the territory and realized the course of the river has changed, they're going to ask questions to try to disqualify you. There's a saying in math that the people who ask the dumbest questions are the ones who have won the most awards. And it's because they can ask whatever they want and no one's going to judge them. Or it may be that they got really good at math because they were willing to ask lots of dumb questions along the way. I don't know. But it is like a correlation phenomenon that's observed where
I would say it's pretty structural. And the truth is that you can't find anything new unless you are willing to challenge the implicit assumptions. So like a dumb will seem dumb if it doesn't take for granted a thing that everyone takes for granted, because people will hear the question and think, obviously you should know the answer to that. I would say you really can't advance any field without things that other people won't question. And if it appears to be dumb questions, then so be it. I think that this conversation sort of strikes at something that is like deeper than education and engineering and mathematics and more to the culture of expertise. On one hand, we have to fight this battle to eliminate expertise entirely is problematic. In fact, I would argue that one of the reasons we have difficulty with token engineering is because everybody's can be a token engineer. And I'm like, yes, but also one who's willing to take the time to learn calculus and linear algebra and a little bit of things like sensitivity to assumptions, learn to make maps. Yes, everyone has the right to learn to make maps, and I will be happy to teach and build tools and work hard to try to make it accessible, but also that is not the same as can make maps. It's like one should have access to both the education and the tools to make maps, but like I am like struggling with that, because on one hand, we don't want to reinforce the disciplinarian where you're saying, prove to me that you know all the things. And like, until you've proven that you know all the things, you don't get to do That's a map copying training. So like, I'm not asking for people to be map copiers. I don't want them to be map copiers, but I also don't think that people have the equipment to go make maps until you teach them, okay, do a little bit of map copying, understand what map is, understand what kinds of tools map make use by copying some maps, but then start to step into the problem and ask, what did creating this entail, as opposed to just what does replicating this entail? Then we can start to have more map makers. I really want a much more map making, like a society that engages in making its own maps. But on the other hand, I can't expect anyone to go through the effort, especially when a lot of this is implicit in software and thus requires mathematics.
What I would say is I think it would be good to increase the expertise, but increase the importance of individual experts. Thank you so much for taking the time to talk to me, and I'm sure we'll talk again.
Yeah, I appreciate all the work you're doing to help teach and get people. And I don't know, we need to go, but I appreciate you immensely.